Welcome to your Algebra 2 Lesson 3.5 on Basic Matrix Operations. Okay, so our objective today is you're going to perform operations, addition, subtraction, multiplication with matrices. A matrix is a rectangular array of variables or constants in horizontal rows and vertical columns, usually enclosed in brackets, and the plural for a matrix is matrices. The entries, the variables or constants in the matrix, are called the elements of the matrix. So here we have an example of a matrix. The element 5 is in row 3, so it's in row 1, 2, 3, column 1. So these are our rows. Rows go across. Here are our two columns. Columns run up and down. The matrix above has 3 rows. Like I said, 1, 2, 3, and 1, 2 columns. The number of rows and columns a matrix has is called its dimensions. The dimensions are always given as the number of rows, R, by the number of columns, C, or R times C. So this is a 3 by 2 matrix. Okay. Here you have an example of a 1, 2 by 1, 2, 3, a 2 by 3 matrix. This one here has one row with 1, 2, 3, 4 baby columns, so it's a 1 by 4 matrix. Here we have 1, 2, 3, 4 little bitty rows by one big column. So this far one is 4 by 1. Equal matrices have the same dimensions, and each corresponding element of one matrix equals the corresponding element of the other matrix. Addition and subtraction, this can be done if two matrices have the same dimensions, and then it is done component-wise by adding or subtracting as you're directed corresponding elements. So let's look at this. So we're going to perform the indicated operation if possible. So I look and I go, okay, I've got a 2 by 2 matrix plus another 2 by 2 matrix, so this should work. So I'm going to add corresponding parts. So I'm going to do 3 plus negative 1. Okay, and that's going to give me my new first row, first column element. Okay, I add the first row, first column value plus the other first row, first column value or element, and I add those two together, and that makes my new first row, first column element. Let's move on to the first row, second column. So 0 plus 4 is going to give me 0 plus 4 there. Then I'm going to have negative 5 plus 2 and negative 1 plus 0. And then I just simplify. So I get 2, 4, negative 3, negative 1. Subtraction is done exactly the same way. So I'm going to have 7 minus negative 2, 4 minus 5, 0 minus 3, negative 2 minus negative 10, negative 1 minus negative 3, and 6 minus 1. So see, it's exactly what we got. You just match up the corresponding elements and perform the indicated operation. And now we simplify. 7 minus negative 2, 7 plus 2 is 9, and then 4 minus 5 is negative 1. We get negative 3, positive 8, positive 2, and then 5. All right, scalar multiplication. We're going to learn about matrix multiplication in just a minute, but right now we're going to talk about scalar multiplication. You can multiply any matrix by a constant called a scalar. It's just another word for the constants that we're using. This operation is called scalar multiplication. It is performed by multiplying each element by the scalar. So let's look at this. If I've got negative 2 times a matrix, I'm going to multiply every element in that matrix by negative 2. So I have negative 2 times 4, negative 2 times negative 1, negative 2 times 1, negative 2 times 0, negative 2 times 2, and negative 2 times 7, and the product goes in the corresponding spot. So we end up with a final matrix of negative 8, 2, negative 2, 0, negative 4, negative 14. All right, now we're going to combine multiplication and addition. So first thing we're going to do is we're going to multiply everything inside that first matrix by 4. So we're going to have 4 times negative 2, 4 times negative 8, 4 times 5, 4 times 0, and then we'll add the corresponding elements in the other matrix. Let's simplify a little first. So negative 8, negative 32, 20, 0, plus negative 3, 8, 6, negative 5. So now, just adding corresponding elements, we'll have negative 8 plus negative 3, negative 32 plus 8, 20 plus 6, and 0 plus negative 5, and that's going to give us our final answer matrix of negative 11, negative 24, 26, and negative 5. All right, there's some properties of a matrix. The associative property of addition, matrix A plus B, and then you add C is the same thing as adding B and C and going back and adding A. Commutative property of addition, A plus B equals B plus A, and the distributive property of scalar K times the sum of A plus B is equal to K times A plus K times B, and that holds for subtraction as well. All right, we're going to solve the matrix equation for x and y. So we've got 3 times the sum of the matrix 5x, negative 2, 6, negative 4, plus the matrix 3, 7, negative 5, negative y equals negative 21, 15, 3, negative 24. So it's definitely an equation. We need to simplify the left-hand side here. So let's do our order of operations. We're going to add first because those are inside the parentheses. We're going to simplify inside the parentheses, and then we will multiply by 3. So I'm going to add inside the parentheses there. So I'm going to do 5x plus 3, negative 2 plus 7, 6 plus negative 5, negative 4 plus negative y. And that's going to give me 5x plus 3 because they're not like terms. 5, 1, negative 4 minus y. Now I'm going to multiply each expression by 3. That's inside that matrix. So I'm going to get 15x plus 9, 15, 3, negative 12 minus 3y. And then we're going to set corresponding parts equal to each other when there's something to solve for. So in the first row, first column, there's an x, so I'm going to set it equal to the other first row, first column. So 15x plus 9 equals negative 21. 15 equals 15 that is true, but it doesn't have anything for me to solve, so I skip that. 3 equals 3, another true value, but I don't have a variable to solve for. And then negative 12 minus 3y equals negative 24. Oops, there's a little typo there. I'm going to fix real quick. That should be a negative there. Get to that point. Okay, and so let's see. If I subtract 9 from both sides, I get 15x equals negative 30. Divide by 15, I get x equals negative 2. Here I add 12 to both sides, I get negative 3y equals negative 12. Divide by negative 3, I get positive 4. And so the solution is x equals negative 2 and y equals 4. All right, matrix multiplication. The product of two matrices A and B is defined provided that the number of columns in A is equal to the number of rows in B. If A is an M by N matrix and B is an N by P matrix, the product of AB is an M by P matrix. So if you look, going in the order that we're multiplying, so we have A times B. Write down the dimensions of A, so M times N, or N by N. Write down the dimensions of B, so N by P. All right, the middle numbers have to match. That means multiplication will be defined. And then the outside two numbers will tell you the new dimensions. So the product AB will have the dimensions of M times by P. All right, we're going to state whether the product of AB is defined. If so, give the dimensions of AB. So we've got 4 by 3 and 3 by 2. The 3's match, so we're going to end up with a 4 by 2 product. Okay, because A is a 4 by 3 matrix, just like I said. B is 3 by 2. The 3's match, so that's great, and we're going to end up with a 4 by 2 matrix. Let's try the part B. Okay, for part B, you've got 3 by 4, 3 by 2. The middle numbers don't match up. You've got a 4 and a 3. That means we're not going to be able to conduct the multiplication, so AB is not defined. All right. Matrix multiplication is probably going to be a little surprising on how it's defined and how it's done. You are going to need to practice, and you're going to need to show your work while you practice so that it becomes second nature. Matrix multiplication is done by multiplying rows of the first matrix by the column of the second matrix, and it involves little multiplications and adding along the way. So we're going to multiply AB times EG, and then we'll multiply AB times FH. And then we move down and we multiply CD times EG, and CD times FH. Alright, so let's look and see how we get this. Alright, when I'm doing first row times first column, I do first element times first element, so A times E, and then I write down plus second element times second element, B times G. I do the same thing first row, second column, so I'm going to have AF plus BH. Now I've run out of columns, so I'm going to move down to the second row. So I'm going to do CD times EG. So I'm going to have CE plus DG. Now I'm going to do CD times FH, and I'm going to get CF plus DH. And that gives me my final product right there. Alright, so let's look. I'm going to find AB if A equals 1, 4, 3, negative 2, and B equals 5, negative 7, 9, 6. Alright, because each one is a 2 by 2 matrix, the multiplication is defined, and we'll end up with another 2 by 2 as our solution. Alright, so we're going to do the first row by the first column. So we're going to do 1 times 5 plus 4 times 9. Now we're ready to do first row times second column. And so we're going to have 1 times negative 7 plus 4 times 6. Okay, and now we're going to do 3 times 5 plus negative 2 times 9. And then finally, we're doing second row times second column. We're going to do 3 times negative 7 plus negative 2 times 6. All right, so now we're going to simplify. 5 plus 36 is 41. Negative 7 plus 24 is 17. 15 plus negative 18 is negative 3. Negative 21 plus negative 12 is negative 33. So that's our product. All right, there is an associative property of matrix multiplication. A times the product of BC is equal to A times B, that product times C. The left distributive property works. A times B plus C is equal to AD plus AC. The right distributive property works. A plus B equals AC plus BC. And the associative property of scalar multiplication works. K is equal to A times B is equal to K times A times B is equal to A times KB. But notice we never move anything as far as order goes with the matrix. Okay, we don't have AB equals BA because that's just not true. There is no commutative property of matrix multiplication. AB does not equal BA. All right, we're going to use some given matrices and evaluate some expressions. So we've got A, B, and C there. And we're going to figure out A, B plus C, and then AB plus AC. All right, A times the sum B plus C means we're going to add B and C together and then multiply. So when we add B and C together, we have negative 3 plus 1 is negative 2. 0 plus 4 is 4. 1 plus negative 3 is negative 2. Negative 2 plus negative 1 is negative 3. So now we're going to multiply 4, 3, negative 1, negative 2, 2, 0 by negative 2, negative 2, well, negative 2, 4, negative 2, 3, negative 3. All right. So again, it's defined because we've got a 3 by 2 and a 2 by 3, and we're going to end up with this 3 by 2. So how did they get the numbers? 4 times negative 2 is negative 8, plus 3 times negative 2, that's negative 6. Negative 8 plus negative 6 is negative 14. 4 times 4 is 16, plus 3 times negative 3 is negative 9, which gives us 7. Okay, so now we're ready to move to the second row. Negative 1 times negative 2 is 2, plus negative 2 times negative 2, that's 4, so 2 plus 4 is 6. Negative 1 times 4 is negative 4, plus negative 2 times 3, that's 6. So negative 4 plus 6 is 2. 2 times negative 2 is negative 4, plus 0 times 2, that's just going to be negative 4. 2 times 4 is 8, plus 0 times negative 3, that's just going to be 8. All right, AB plus AC, we're going to do our multiplication first and then add. So same process for the multiplying. And so we get negative 9, negative 6, 1, 4, negative 6, 0, plus negative 5, 13, 5, negative 2, 2, 8. Take time, stop, and make sure you get the same thing when you multiply. Remember, we're doing the rows times the columns. So let's see, that would be negative 12 plus 3 is negative 9. 0 plus negative 6 is negative 6. So go through and do that and make sure you come up with the same values. Now we're going to add, so we're just going to do negative 9 plus negative 5 is negative 14, and so on. Negative 6 plus 13 is 7. 1 plus 5 is 6. 4 plus negative 2 is 2. Negative 6 plus 2 is negative 4. 0 plus 8 is 8. Okay, that's it for your examples. Do the problems to try on your own. If you struggle with anything, either go back and rewatch that part of the video or come in and see me, but you need to have those problems to try on your own attempted before you come to class. Thank you so much for your attention and for taking notes. I will see you soon. Bye.